All right, good afternoon, everybody. Thanks for joining us here in the Chubb Marquee. Today we're looking at equipment and technology as a stream this afternoon. I want to thank everybody for taking the time to join us. We have a range of 5 speakers joining us this afternoon, each with their own specific discipline that we'll touch on as they come up to present. And they'll have 15 minutes. At the end of each of their sessions, we'll have a little bit of time for Q&A from our online audience. And then at the end of the overall group, we'll open up to the floor. So I'd just like to share a little bit about Chubb Fire and Security, obviously sponsoring the tent today. Our core business is fire and security access, protecting people and assets. The unique risks emerging from the waste and recycle handling industry is of keen interest to us, and we are very involved in some bespoke solutions to meet those emerging challenges. My particular stream is vehicle systems, so we support currently a number of local councils around the country with fire protection on each piece of their mobile equipment, as well as our more bespoke solutions with consulting and design of specialist fire protection in the unique applications. So first of all, we have Jake Henderson. He's the National General Manager and Sales and Business Development for HSR Southern Cross, involved in truck sales. Thanks, Jake.
Just hit the button whenever I'm good. So if when I press play, that's going to play. Can we go back? Sorry. I don't get to choose when the slides move. Let me ask you something simple. Have you ever wondered why you are the way you are? Why you choose to buy what you choose? Why you react the way you do? Why you get angry, scared, jealous, or stuck overthinking? The answer isn't magic. It's not fate, it's your brain. Every thought, every fear, every habit, it's wired into you. Sorry. Every thought, every fear, every habit, it's wired inside you, in your neurons from all the data you've collected in your lifetime. Your behaviour isn't who you are, it is what you've learned to survive. You weren't born to be afraid to fail. You weren't born thinking you are not good enough. Your brain has just built those walls to protect you from pain, but here's the truth. Neuroscience shows us that your brain can change. It's called neuroplasticity. Every thought you repeat, every action you take, every belief you reinforce, rewires your mind. You're not stuck, you're just rehearsing the same story. What if you chose differently? What if you trained your brain to see possibility and not fear? To build habits of courage, not avoidance. Yours and your colleagues' behaviours are not your identities. It's your script, and you, and only you, are the author. So today, when you listen, and you think this is probably already a TED Talk, I'd like you to consider, am I choosing to live by default or by design? Your brain is ready to follow the story you choose to tell. Just as you have the power to choose your internal story, you also have the power to choose what you support, what you invest in, whether that's beliefs, behaviours, or products. For decades, many have accepted the norm of purchasing waste equipment manufactured overseas or owned by foreign multinationals. Today, you have the choice to act differently. We proudly represent the only certified Australian-made and Australian-owned waste equipment manufacturer. We are not just another option. We represent innovation-driven, homegrown solution that empowers local communities, supports the Australian economy, and ensures quality, reliability on home soil. Choosing our equipment means choosing sustainability, national prosperity, and excellence grounded in Australian craftsmanship. Our products are not only designed for the unique needs of the country, but are also built with a commitment to safety and environmental standards that resonate with the value of buying local. By supporting Australian Made, you're investing in a future where choices align with community growth and environmental responsibility. You're partnering with a company that shares a vision for a stronger, self-sustaining Australia. We understand that time is of the essence in any operation. That's why our streamlined production processes and local manufacturing capabilities allow us to offer industry-leading lead times. You can expect prompt delivery without compromising on quality, ensuring that your equipment enjoys the Australian expectations. Our commitment to maintaining a robust inventory of chassis stock means that we're able to meet your needs, no matter the scale or your specifications of the equipment you choose. This readiness lets us adapt quickly to changes in demand, customise solutions without typical delays, experience with overseas imports and suppliers. With a national service footprint, we're not just a supplier, we're your partners in every step of the way. Our extensive network of service professionals across Australia ensure that you have access to support and maintenance when and where you need it. Whether it's a routine service or urgent repairs, our team is there to keep your equipment in optimal condition, minimising downtime and maximising productivity. Our close proximity to our customers allows us to tailor-make solutions specifically for your unique needs and challenges. We take pride in building relationships that go well beyond the transaction, where customer satisfaction and ongoing support are the forefront of what we do. Embrace the difference with Australian-made waste equipment designed and manufactured by HSR Southern Cross. Experience unparalleled efficiency, reliability and support, hallmarks of an Australian company committed to excellence and the betterment of our industry. For this week, our stands are on the right, 11, 12 and 13. If you have any interest in having a chat to us about our hook loaders, skip loaders or rear loader compactors, please come and see me and the team and we'll be happy to show you through our products. Thank you. Let's take questions. Thank you.
All right, thank you, Jake. It's great to draw attention to our local Australian design expertise with that local support and timely response with our emerging needs. Sorry, I keep getting alerts to update my app. I don't know if anybody else is having that today. Next up, we have Philip Parbury from Tomra Collection. And Philip will talk a bit more about the coin deposit schemes. Welcome, Philip.
All right, good afternoon, everyone. Thankfully, the rain stopped, so actually everyone came out of the tent. I thought I'd be presenting to an empty room this morning, to be honest. So I'm Phil Parbury. I'm the core service manager at Tomra Collection Australia. So it's kind of my job to make sure that our infrastructure keeps working. Today, I'm here to talk about Tomra's technology and accessibility and how our journey, to make CDS and circularity even more accessible. Okay. But first of all, who are Tomra? Yeah, it's not a very well-known name in Australia. Tomra Collection is one division, and it's our vision really to lead the resource revolution by transforming how we obtain, use, and reuse the world's resources. You know, we're a global company. We've got presence in over 60 markets worldwide, just as a collection division. Over 5,400 employees and over 85,000 machines worldwide. We've been doing this for over 50 years. I haven't been doing it for quite that long. But we have a lot of experience, a lot of innovation behind us. So I like to think we know what we're talking about when we're discussing contained deposit schemes, because that's really what we do. We spend a lot of time developing solutions for contained deposit schemes around the world, and including Australia. As I said, global presence, a lot of presence in Europe, but also in Asia-Pacific region. We've got over 2,000 machines across Australia, many of them in New South Wales. Why does Tomra exist? So around the world, about 500 billion plastic bottles are bought and sold every year. It's quite a big number. And if you expand that number to all types of beverage containers, that grows to about 1.4 trillion. So it's, a lot of containers. And only a small fraction of those are actually recycled. A lot of them end up in landfill in different parts of the world. And it's a big contributor to over 8 million tons of plastic that enter our oceans every year. And that's where TOMRA comes in as part of supporting container deposit schemes to try and divert that away from landfill and divert that waste stream back to closed loop recycling. And as part of that, we collect over 48 billion containers a year so far, and we're obviously looking to keep growing that. It was actually TOMRA that invented the reverse vending machine that we use in container deposit schemes. We've got our founders up on screen here, Tora and Petr Planka. They really had the vision to bring automation to container deposit schemes. It's been a container deposit scheme has been a function in Norway, where our head office is, where our founders are from, for almost since the beginning of the 20th century. So they've been doing it for a long time. It was only in the 70s that automation started coming in through TOMRA developing the technology. We've still actually got the first reverse vending machine in the world sitting in our head office there. Changed a bit since then. Back then, you actually had to return the container standing upright, which was the design at the time. But it's really that culture of innovation and continuous improvement that our founders installed in us that we brought forward throughout the years. All the way from the beginning of the kind of automation in this space in the 70s and through the 80s and 90s, and bringing that all forward to what we have now, our latest and greatest units, which we've successfully just deployed as the technology partner for the Tasmanian Recycle Reward Scheme. We're proud to be the one half of the joint venture of the TOMRA Cleanaway network operator for Tasmania. It's been a great start. Over 1 million containers were returned in just the first 4 days. It's only been going now for not even 2 weeks yet. So we've been a great start. And that's going to really contribute to help increasing that number of containers, again, diverted away from landfill and diverted back into a proper recycling and reuse and circular economy stream. Let's bring it back to New South Wales. As I said, the technology is continuously evolving. We're continuously coming up with new ways to service our customers, provide different solutions to meet our customers' needs, and provide access across different locations by adapting to those environments. I think a lot of people will be familiar with our reverse vending kiosks that form the backbone of the network. We have about 350 of those across New South Wales. We've also developed our larger format reverse vending centres up in the top middle there, which are suited more for the kind of lighter industrial areas in bigger formats, bigger populations, but also our smaller format standalone machines. Again, quite well suited to where spaces are more of a premium, so kind of more inner city metro. But that's all well and good, but how does that actually deliver results? Well, in New South Wales, since the scheme went live in 2017, we're up over 13 billion containers collected, which is a great result. It's over 2 billion a year coming through that state scheme. That's over $1.3 billion paid back to New South Wales recyclers, and over 1.1 million tonnes of material recycled. So, I'm really proud of those numbers personally. And a big part of the scheme is our charity partnerships. We have over 300 charity partnerships as part of the New South Wales Return on Earn network, and and it's really working closely together. Then we see even better outcomes for local communities. But the innovation journey continues. Doesn't stop here. We've got lots of wonderful things that we've been developing and recently launched, including self-service bulk tipping technology, which is actually operational in a couple of sites across the state now. Improving what our customers already like with the reverse vending kiosks, the next generation of those, and learning from what we've seen in the markets across Australia. And we've even got our latest development is actually here today. So if behind the tent, we've got our mini kiosk, and it's, again, another great solution to meet different needs. And come along, have a look, come speak to our friendly team if you have any questions and would like to learn a bit more about it. So that's me. Thank you very much. Any questions?
No, we're not. I haven't got questions coming through the feed, guys, so I do apologise, but at the end we'll open to the floor and please share. Look, Philip, that's the recycling container depots are a great initiative, and I suppose you guys are to blame for me running my father-in-law to the recycling centres probably once or twice a month to grab some money back for his tins, like he needed some more. Next, we have, Ian Pritchard from NVAC. He'll discuss some of the new technologies for vacuum collections.
All right, so this is the clicker. I'm an electrician, not a public speaker, so bear with me. Right, so that's on the next screen there. Yep. Right, so I'd like to introduce myself. My name is Ian Pritchard. I work for the NVAC, and I've been working there for the last 4 years, and my expertise is in electrical. I'm an electrician, and I'm also an electrical engineer, and so I've lived and breathed that. And I got into the waste industry because my father said, you've got to get into waste because there's always a job, people are always making waste, so it's kind of cool that I followed my father's footsteps. So NVAC is a multinational global leader in vacuum waste technology. And I guess it's looking at an alternative way of the traditional rubbish method of a truck going around to 50 different locations picking up rubbish and then taking away bins, blocking footpaths, smells, noises, disturbing people in the middle of the night. So the automated waste system is imagine like a sewage system, but everything's underground. And so the bins empty themselves via a trapdoor below, and then it all goes to one location. So instead of having 50 bins picked up from multiple locations, all the rubbish goes via vacuum pipe underground to a collection station, which is, and we have one 30 cubic metre Ro-Ro bin, which is fully sealed. So that gets taken away to either the MRF or the materials recovery facility, or to the landfill. So it's a good way. It's basically a waste transport system. All right, so NVAC, just as a bit of a background, they're operating in 32 countries around the world, and they're just new. We've been doing it for 40 years. So this is not a new innovation. This has actually been around. It's just new to Australia. So it's a well-proven method. I'll just go to the next screen. So I'd like to talk today in particular about our Australian project. I mean, yes, things work overseas, but are they really built for Australia? Well, our Australian project is a good example of what we might be able to do. So here we have a precinct-wide development. So we start off with a greenfield site that used to be a golf course, and we said, let's, the mayor of the Sunshine Coast said, look, the Sunshine Coast it's like a big sleepy beach community. Anyone been to the Sunshine Coast before? Yeah, it's a beautiful place, and it's not the buzz of Brisbane, but it's becoming a bit like that, and we needed a proper CBD in order to operate our, to attract big businesses and attract employment to the region. And so the mayor went all around the world looking for ideas on how we can do this CBD better, because it's a greenfield site and we can design it from the ground up. So he looked at ways of doing transportation and ways of doing communications, and then he's looked at rubbish. Well, how are we going to do rubbish? And then he saw, when he was in Sweden, this NVAC system, so the underground pipe network, and he said, oh, this is great, let's adopt it into Maroochydore. And so now that's been his legacy. So now we've been operating, it took about 3 years to build, and we just, at the same time as we're putting the electricity and water reticulation into the ground, it's just been one extra service in the trench. So it wasn't a big deal to do the installation. As long as you're doing it at the start, you wouldn't realistically put this in at the end of, you wouldn't retrofit it into an existing city. So basically they gave us a concept master plan of how they think the city might be, and obviously we can make it flexible. And then we did a, so we could do a basic pipe design and then leave flexibility to see how they might want to connect into it. So we can leave various pipe stubs into different lots depending on what kind of building might be there in the future. So we do a concept design, so then we can get an estimated cost on what it would cost to install it. And then we have to build a place for the rubbish to come to. So we built a collection station. Now these can actually be underground. They don't have to necessarily be above ground. So in Singapore, for example, you might have 4 residential towers and then the collection station is actually built underground. And if you have time, I've got a booth inside and it's got a really cool model of how it all looks underground. So in Maroochydore, we built a collection facility. It's about a 10 by 15 metre building and we're lucky to have it above ground. And then this here is the pipeline as it goes in. And again, it's about a 500 millimetre steel carbon pipe. We thought we could go a little bit bigger, but then the efficiency drops off. We're trying to vacuum waste from about 1.5 to 1.6 kilometres away. So that means we can get in about 10,000 people or about 1,000 households roughly, plus commercial and sort of restaurants. So this is what it looks like, the pipe going in the ground. And this is the pipe leading to, well, this is what the collection station looks like now. So it's not some big gaudy building that is ugly. No one even realises it's a rubbish collection facility because we've got loyal officers right next door. They don't smell anything. It's all completely sealed. So each private lot then has the option of how they're going to connect into our system. We've got these bins. This is the basic system where the bins sit on top of those metal platforms. And then there's like a hopper below the ground, and just where the horizontal pipe, there's like a trapdoor that opens up. So this is what it looks like, and then obviously the ground slab of the building will go on top, and that red gooseneck pipe at the end there, that's where the air vent comes in. So it allows air to drop in, and then it's a river of air underneath the bins, and then it just drops one bin at a time, 8-second gap, next bin. So it just drops them all one at a time. All right, so we've also got options within a building. We can run our pipe straight into a vertical chute network. So again, there's no double handling of bins. As you can see, the vertical chute at the top, and then we have a 2,000 litre tank. And so the NVAC system, that tank fills up all day, and then we push a button with our computer at the system. I can actually run the system from my phone right now if I wanted to. It's like fully automated. I can set it to run at 4 o'clock on Sunday afternoon. I don't have to be there. So if we've got a special event on the CBD, and just say you're going to roll out 20 wheelie bins just to cater for the food trucks, well, I can just tell the bins nearby, empty every 15 minutes, please. So you've got that really cool flexibility. So with the accumulator tank, it just empties once a day, but again, if they fill it up twice a day, it's just a click of a mouse, and then there's an auger screw, and then it just feeds it in, drip feeds it into the pipe, and away the rubbish goes. Right. And so this is the commercial inlets. We've got a city hall, and this is how those systems run. This is more of a basic setup, but we have commercial cleaners within the building. They bring the rubbish down in carts, and then they open up the doors and put the rubbish in, and restaurants feed their rubbish in there as well. So as you see, we've got yellow and red, and unfortunately education is definitely our biggest issue. Teaching people to put the right thing in the right bins is still a drama for us, but we've got good signage and everything. I think it's still well perceived, and we do look in our bins from time to time at the other end, and we can see that people generally do the right thing, but not always. So I had the great pleasure when we first, because it's an Australian first, we had the Today Show do a little article on the system, and I thought it was the best little summary of how our system works. So I'll just put that on. You can watch that for a second. I don't know if you have to turn up the audio. Is there an audio feed on the video? Sorry. Oh. Yeah, so the Today Show came and interviewed us, and then no? Okay, sorry, that's all right. So anyway, it was really cool that they came and sort of did a bit of an overview of how the system works, and it went on around Australia, and we did get a lot of people interested because of the Today Show. It shows how obviously that's a diverter, where the biggest expense of the pipe system is actually the pipe itself, not the collection station. And by having the fact that we can actually draw all of our waste through the one pipe, and we just have a diverter that allows us to fully cleanse the pipe of all the recyclables, then we collect all the rubbish, general rubbish bins through the same pipe. So it saves a lot of costs on the capital expenditure. So this is what the big bins look like. That's the public bins out in the street, and that's how it looks like underground. So the trapdoor, and then it signals empty one bin at a time, and here's the separator. That's my old work friend, Scott. So he's explaining that's the pipe network when it comes out of the ground, and that's the diverter shifting over between recycling fraction and general waste fraction. And that's the big bin, so 30 cubic metres, we can squash a week's worth of rubbish into there versus a rubbish truck going once a day to lots of different locations. We can squash a week's worth of rubbish into one bin. So, but as the CBD gets bigger, obviously we might have a bit more. Right, I think that's enough of the video. So that's the separator. That's a lot of our ingenious. How can we draw rubbish from a kilometre away or 1.5 kilometres away through a vacuum? It's all in the shape of that cylinder inside. It's a real innovation of how it's like a helix inside, like those water slides that you hop in the top and it spins you around and drop out the bottom. It's a bit like that with the rubbish. So, but again, the whole system's sealed. You see how clean the floor is? That's how. That's what it's like today, because there's no. You wouldn't think you're in a waste facility. It's a very good place to work. So we have a SCADA control computer, and that basically monitors the whole system. So I can even team viewer into that now, and I can look at all the bin status. It doesn't automatically run when the bins are full. We can sort of learn those trends through statistics gathering. We can even weigh the rubbish at the bins. If you want to sort of say how much rubbish is Mrs. Smith using, well, then you can actually charge that back. There's so many different platforms you can create from this basic vacuum cleaner. So this is one of the ladies using one of the public bins on the street. Again, it looks like something out of Doctor Who, but you can make the bin look like whatever you want to according to the architecture of your building. So that's the collection station pipe network. Yep, and that's me doing. So we have just 2 people do all the maintenance on the whole system. So it only takes really one of us to operate it, and 2 people just because there's a few 2-person tasks. So it's really minimal on people, and all the air does the heavy lifting. So these are the bins where the rubbish goes in, and this is the history of the Maroochydore CBD. So yeah, it started 2017 when they removed the golf course, and now we've got 10 buildings, but a mixture of all different types of tenancies from a city hall to, we've got a little private hospital going in now, commercial towers, restaurants, and all their waste gets handled by this system. And so this is what the collection station looks like. As you see, it doesn't look like a gaudy waste facility. It actually looks fairly pretty. So it's a really good place. We use it like a last mile logistics hub in a way, and we're going to start getting deliveries to then farm out into the CBD by little electric cars. The idea is to keep the big vehicles and trucks off the streets in the CBD, and they're designing them in the master plan for more open walking areas and green spaces rather than big roads. So there's a few stats on the project as well, but in summary, thanks for your time. So these are some of the key benefits of the AWCS over the collection methods. So it greatly reduces road congestion due to reduced vehicle movements in the CBD. There's all sorts of studies have been done about that. Improved hygiene and reducing the risk of infection, particularly in a hospital. Cleaner and quieter environment. So low operational costs definitely is the biggest thing. Available 24/7. Even we had a big cyclone. I mean, Queensland has, up in the north we have big cyclones, but we actually had one in Queensland, in Brisbane, for the first time ever, and we were all like freaking out, taking all the toilet paper off the shelves and in Aldi. And everyone's scared. The traditional rubbish collection method stopped completely for 3 days due to safety issues, but we just kept collecting like normal, on time, every time, because all our infrastructure is obviously underground. And so optimised urban space. Architects are always having troubles with where to put bins in building basements. Obviously, if we've got bins that are emptied 4 times a day, then we don't need as much a bigger bin, because a normal bin, obviously you might have a big 1100 litre bin, takes a lot more space than a smaller one, but we can process the same amount. So it gives them more space for working with design of buildings, and obviously increased efficiency. I mean, you think it uses a lot of electricity, but it uses about 300 kilowatt hours a day to run the whole system. And to put that into perspective, my house uses about 20. So it's not that, for a commercial grade, a bit of equipment, that's not much power. So it's certainly very good. Right, that's the end. Certainly if you've got any questions, come and see me at the booth inside. And yeah, it's great to introduce something cool and new to Australia. And I think it's definitely the future of of waste in some regard. Yeah. Right. Thank you. Sorry. Okay, so the capital expenditure, I'm glad you asked. So the collection station, $8 million, right? And that does 40 buildings. That'll service 40 buildings, and the pipe's about $12 million. So you're looking at 20 million total. That's all the public infrastructure that the council owns. And then the individual apartment building, whether it's a city hall or like Holiday Inn, we've got a hotel there. They can choose then how tizzy they go. If you want to go top level, you can get a duct that goes right into the individual apartments, into your island benches. And they've done that like in Gangnam, which is the Beverly Hills of Seoul in Korea. So you can go top end. So each developer can then choose, I think it's like 150 to 200,000 per building, but that's paid for by the developer. And then you can go high level but again, it's just the same pipe coming into the system. So you've got options, you know. Yeah. Yep. Any other questions? So at the moment, we've got 9 currently feeding into the system, but there'll be about 40 altogether. Yep. And we're going to have a stadium there as well. It's very suited to stadiums. We're hoping to get a system into the new Victoria Park Olympic Stadium for the Brisbane 32 games. And we have one in Wembley Stadium in the UK. Yeah. But if you go on the NVAC website, it shows all the projects around the world. Yes? Very good question. I didn't touch on that. So the air obviously is used to transport the waste, and then it's separated off from the waste by gravity in what we call the separator. It took them a long time to figure out that name. So the air is then goes through the motors where it's obviously heated up due to friction. Now, hot air obviously is smelly, isn't it? So what we have is a carbon pellet system and a cooling system. So basically it cools the air, and just by cooling the air alone, we actually reduce 90% of the odour. And then we have a dust bags. So it runs through a dust filter first, cooling system, and then a carbon pellets. So then when the air is released, there's no odour or smell. And like I said before, we've got lawyer offices right next door, and if there was any issue of smell, they would have been on the phone straight away. And in 4 years, we've never had a phone call, so we must be doing something right. Yep. 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 Okay, thank you. But yeah, come and see us at the booth and talk more.
All right, yeah, thanks, Ian. That's was an interesting topic. Some ladies I was having lunch with were very interested about. They're involved in some development approvals and things like that, where the spaces are becoming tighter streets, more house density, and clearing that rubbish as exactly as Ian's described, is removing additional trucks and vehicles from the streets. I had a question arise as you were talking that you answered along the way as well. I love the fact that the same pipe network can clear your regular waste as well as recycling, using the same circuit through the diversion process. So really cool. Nice initiative. Thanks, Ian. Guys, next we have Andrew from Concept Tanks. Thank you.
All right, thank you, Stephen. We're up and running. All right, ladies and gentlemen, thank you for joining us this afternoon. I know I stand somewhat in between you and afternoon tea, and I'm hoping the rain holds off. But my job for the next 15 or 20 minutes is to change your mind about tanks. And you're probably wondering, how on earth am I going to do that? Well, Concepts as a business, while we do tanks, absolutely, and we do service the waste industry, we are an innovation that has spanned probably the last 15 years since the business was born. By and large, we replace dams and large ponds. That is the space that we play in. So I'm going to take you through that. And you're probably wondering why I've got a photo of the Gabba up here. We are a Brisbane-based organisation, so I know I'm in Blues territory at the moment, but the Gabba's been the source of a lot of conjecture over the past probably 12 months around where are we going to hold the Olympics. And you're now probably wondering, what on earth has that got to do with tanks? Well, to give you a sense of our business and the scale that we play in, Our largest tank deployed at the moment is the size of the playing field of the Gabba. So it's about 78 megalitres, 178 metre diameter. So for any budding golfers in the room, if you can drive 200 yards, you'd probably just clear it. Design's in progress. Our next goal is the MCG. That's where we're going. It's cricket and AFL fields. But we do play at smaller scale, so size isn't everything, and I'll talk you through that in the next 15 minutes or so. So a bit of a snapshot, as I mentioned, 15 years the business has been in operation, so we come from innovation, but we do thrive on disrupting large dams and ponds in that 15 megalitre and above territory. Of course, we provide under 15 megalitres, but this is the differentiator that we provide to market. So a few facts and figures around the board there, but I guess the one that we're most proud of is the fact that we are 100% Australian-owned, operated and run. So we do operate nationally now. Our headquarters is based in Brisbane. And very proudly we support multiple industries. Although we started in energy and oil and gas, we now do cover waste, utilities, resources, construction, renewables, has been a fairly new addition to our suite, and many more. Okay, so I'm just going to take you through some industry challenges that we understand that have been out there, and this is where we come from, and it's largely around the trends and challenges around large earthen structures, dams and ponds. So I think most people will be aware that this day and age, it's no longer a case of moving dirt and putting some liner in there, as it would have been years and years ago. These are large dams and ponds are regulated structures under legislation these days. They often come with very, very lengthy approval timeframes, developmental approvals, a lot of engineering up front. We're seeing increased regulation at the federal and state level. And one of the most recent additions, as everybody would likely be aware, is around the ESG pressures on business these days. And that's not only around the licence to operate, but also the social licence to operate, around remediation of sites. So 50 years, 60 years down the track, how are these facilities and sites going to be remediated? And they're big challenges. And the ESG is also now driving capital. So bonding facilities on major facilities. So financiers looking at how this is going to be managed for the long term, which impacts insurance. And of course, quality goes without saying. So with that increasing regulation and ESG pressures, there really is a demand for whole-of-life solutions and thinking. And for any budding directors in the room, there's no greater motivation than our legislation in this country, which services as well. But EPBC Act at the moment has us at 1.1 million or 7 years for unfortunate directors who might get it wrong. So there's a fair amount of attention on this. At the project level, these challenges for earthen structures, they actually go a lot deeper than what we see on the surface. But I guess when we're looking at these projects up front. Sizing and approvals are one thing. I often refer to the need to eat the elephant in one bite when it comes to dams and ponds. Conservative engineering is required. The 1 in 100 year events need to be catered for, and we're seeing those not 1 in 100 years anymore. They're 3, 4, 5 years apart. So the need to go big and eat that elephant up front is paramount, and it's driving up the cost of business. There's a real lack of modularity for solutions when we're talking about earthen structures. Materials become a challenge if you can't win engineered clays and other materials on site to form the structures. And of course, the timeframes are a big challenge. Upfront engineering, developmental approvals, and construction on site. So really struggling with that lack of alternates. And I guess I term this learned acceptance and tolerance for these challenges in industry. And it's this tolerance of high cost, long timeframes, DA processes, low modularity, and then regret spending. You don't get any money back for these at the end of the day. And it's restricting our competitive edge. The third and last challenge, I'll move on from challenges in a minute, is around the all-important liner and containment systems. It's often forgotten about and sometimes poorly understood. So the need to select the right material to contain environmentally sensitive fluids involves a lot of chemistry and a lot of upfront consideration. So that quality comes into play from the very start. But below the surface, quality becomes paramount. And this includes that end-to-end handling, so chain of custody management, right from the OEM to the field install, through the life of the product is critical. because a failure of that containment liner means a potential leak to grade, and loss of containment is where you can come unstuck very, very quickly and undermine your licence to operate. Quality in welding, workmanship. This liner systems are often poorly understood and oversimplified. And they're oversimplified until, I guess, there's a realisation that they're not simple and that you need the experts in there to get this right. So I guess there's a real challenge around bridging that knowledge gap in industry. Education around these liner systems is critical for that end-to-end management of managing containment of environmentally sensitive fluids and demonstrating certainty, which is really, as I've mentioned before, it comes back to that ensuring the licence to operate. So you're probably thinking, well, where does that leave us? You know, this is a bit of doom and gloom, and I'm sorry I've painted that picture, or maybe I'm not. But there is a better way, and that's where we come in as Concept. So hopefully that video is playing for you. I haven't got sound today, but what you're seeing there is the innovation that Concept came up with 15 years ago. It's inherently very, very, very simple. The structure itself is precast, pre-tension concrete panels held in specially designed steel posts with a post-tension cabling system around the outside. That's the structure. Because of that design, it minimises the need for ground preparation. At the very simplest solution, we're talking 100 kPa bearing capacity preparation. So it's very, very easy to construct. The liner system that you can see going in there, that's the all-important, often misunderstood system. We'll get a bit of an aerial shot of what this looks like. This is a 56 megalitre tank in Queensland, about 140 metres diameter, designed for evaporation. So this is coal seam gas wells, where 90% of what comes out of the ground is water, and it's brine, and it's quite hazardous. So it needs long-term management. So as a quick snapshot of the solutions that we provide, that precast engineered structure. These are patented solutions. So post-tensioning with our specially designed patented posts. These are fully engineered, relocatable modular structures. So one of the big benefits that we provide our operators with is the ability to remediate these sites and relocate the assets, repurpose them down the track in future. If you compare that to a large dam or pond, you're talking significant costs just to remediate and rehabilitate, with no benefit for the business or the wider community. And of course, the all-important liner system, this is where we do come into our own around that liner management, end-to-end chain of custody and quality management to make sure that's right. For waste specifically in leachate, there's an advanced leak detection system that we offer because of the criticality of the fluid. So I'll talk through a little bit about that in innovations, just skipping through what I've covered before around the modularity, the scalability. These can be custom designed very, very easily, adapted from existing designs. Minimal earthworks, as I've mentioned. Rapid construction is another key benefit that we see. So in the case of that 56 megalitre tank that you saw, that was constructed in a little over 3 weeks from starting in field. Comparing that to an equivalent pond or dam, you're talking months. So it's very, very easily and rapidly deployed, and then rapid remediation. It's bare earth preparation. Remediation becomes very, very simple when these get moved on. We have designs for 100-year design life, typically around 50 for the one that you saw there on screen. So they are designed for short-term and long-term, giving surety for customers. So I'll talk through some of the applications here, but at the very, very top end of applications for fluid storage, we really find that there's 2 buckets that this falls into: evaporation promotion or evaporation prevention. Sometimes, most of the times for leachate on the east coast of Australia, evaporation absolutely until it rains, and then we want to stop it. So that's our next challenge to solve, and I'll go over that shortly. So when we're talking about the types of fluids, environmentally sensitive fluids that we contain, the list is very, very long, and we have proven applications across the country and across industries. So that includes leachate concentrate, tailings concentrate for mining and mineral processing, process liquors, brine concentrate, and then water in its various forms. So that could be raw water, processed water, produced water, potable water. So we do cover that utility space in potable water as well as sensitive fluids in the case of leachate, where it needs special consideration. The industries, and I've mentioned this previously in the preceding slides, we've now moved from just oil and gas 15 years ago to, I guess, a wide range of industries that are seeing benefits from the concept solutions for helping them, I guess, store their fluids and sensitive fluids in industry. So that covers construction, oil and gas and energy, mining, utilities, water, waste and resource recovery, agribusiness. We have some bespoke solutions deployed for salmon farming in Tasmania, as an example there. And more recently, renewables and pumped hydro. And this is where we start to move beyond containing fluids that people may or may not want to actually making use of them and turning them into power generation. So dual use and dual application. An important topic that I'll cover for the next few minutes is around liner systems, and it's particularly important for waste and leachate management. So really here, this is where we've taken it upon ourselves to own and be accountable for this liner system integrity management from end to end. And that starts at the OEM, where we have partnerships with global providers, trusted, high quality providers, managing that chain of custody from the OEM right through to the install and then through the life, in some cases, through the life of the asset with our customers. Giving surety around compliance, but around the containment, most importantly. So, of course, adhering to international standards that apply here. There are codes of practice that exist for liner management. And again, this comes back to the point I made earlier around a real lack of awareness that seems to be out there, I guess not necessarily in waste, but in other industries, around just some of those specs and standards that are there that need to be complied with for best practice, which is where we've really driven our business to make sure that we can provide those quality products and that certainty for longevity for customers. The ongoing monitoring is critical, but when it comes to quality, we've really driven our business to make sure that we self-perform the most critical aspects of the job, and that includes this liner system. So that's handling, welding. We've vertically integrated. We now own a liner fabrication and handling facility in Brisbane, so we can give greater certainty and quality to our customers over the life of the products. Leak detection systems. Interestingly, our leak detection systems, in some cases, have to be intrinsically safe, explosion-proof. The two applications where that appears, oil and gas, for obvious reasons. There's fluid coming out of the inlet pipes that may or may not contain methane, so there's an explosion potential hazard there. And the other application is actually leachate, where anaerobic conditions can exist, produce methane, and then we enter intrinsically safe EX requirements. But we do cater for that, absolutely. And the 80 years of experience, that's around our core crew. So a majority of our field crew has been with us for 15 years, which is something that we hold really proud for the business. And that gives us that key experience around liner management. So I'll talk quickly through the solutions. When we're talking about the waste industry, it is most often that we talk about our concept tank. The original solution that was provided, that's the one there on the left-hand side. And we can cater for volumes from 0.6 megalitres, so 600 kilolitres, all the way up to designs now for 100 megalitres. For leachate, because of bunding requirements, EPA requirements around 110% bunding, we typically find the sweet spot is, I guess, around that 10 to 20 megalitre sizing, maybe up to 30 megalitres, depending on what bunding options are available for site. The bigger guys, that's where we'll see large evaporation ponds or large evaporation tanks, I should say, being set up in areas of net evaporation, promoting passive evaporation. We do offer the industrial range. These are the big guys, 8.5 metre wall heights. We have the photo you're actually looking at there is BHP Nickel West in Kwinana in Western Australia. A 70 megalitre tank and a 50 megalitre tank. These were specifically put in as the plant entered long-term care and maintenance. It's a nickel refinery, so it's going to be mothballed for a while, to replace ponds that were located 10 kilometres away. And there was concerns around the integrity of those ponds, but also the pipeline that connected them. So BHP took it upon themselves to put storage on site at the existing facility, and that's what you're looking at there. And that's holding back, processed liquor concentrate with a specific gravity of 1.25. So it's quite viscous. And we do offer steel rentals, as a quick mention there, rapidly deployed steel rental tanks, short or medium term deployment, really working with customers to find the best solution to meet their needs. So I'm going to hone in on leachate in the waste sector specifically. So we are really proud over the past 18 months, we've developed a leachate specific solution because waste has specific needs. Leachate is a particularly hazardous substance to contain. And working with customers across Australia, we've now evolved this product into a specialist containment system for leachate. I mentioned the image that you saw previously was processed liquor off the back of the nickel refinery, specific gravity of 1.25. Our leachate solution now caters for specific gravities up to 1.3. So to give you a bit of a reference point, that's glycerine, if you could imagine that. So why that's important is because of the structural integrity of that, I guess, concrete reinforced structure that you see there. It can contain it. It is slightly larger than normal, but it allows operators to freely operate up to specific gravities of 1.3 without concerns around compromising the structure. Increased durability, so design up to 50 years. Corrosion protection, because of the nature and the high corrosivity of leachates, these solutions are now provided with all stainless steel fittings, as opposed to mild steel or galvanised. Still maintaining our configurable modular system, so these can be resized over time, redeployed, and repurposed. So it's a little bit of a circular piece there that I guess is a natural byproduct of the design. Excuse me. The all-important liner and leak detection system is one that we can't forget about when it comes to leachate. So as a minimum, double-lined system using GeoVolt. GeoVolt is a special geomembrane that's placed underneath the liner to make sure that we can test every square centimetre for leaks or defects so that we can correct them before we introduce leachate. So it gives absolute certainty around that quality before we are introducing leachate for customers. An enhanced leak detection system. So all of these systems must have a leak detection system, and that includes ponds and dams for that matter. This one is enhanced for greater traceability and visibility through the life of the asset. As I mentioned before, intrinsically safe, interesting requirement, but if these systems turn anaerobic, especially with covers on, must be able to cater for that generation of methane. And I've just mentioned the floating cover. So these are optional, engineered floating covers. We're not talking about tarps pulled over the top of structures with ratchet straps. They are fully engineered. We have some case studies at our stand here today and for this week. So they're designed with walkways, access ports, vents, and other features built into them for customers. So just a couple of little case studies here around waste. What you're looking at here is a 10 megalitre tank at Remondis in Ipswich, just outside of Brisbane. So this one was installed in 19 days. Excuse me, as a reference point around that rapid construction, specifically designed for leachate again. This one doesn't have a floating cover installed, wasn't deemed to be necessary at the time, but it can be retrofitted down the track. And the next one I've got here is a little bit smaller. It's to give you that sense of scale. We can go up to that 78 or 80 megalitre, but we can go right down to 1 megalitre. And this is one that's been installed for Whitsundays Council in North Queensland. It's a little bit different to the previous ones that I've showed you because it actually has a concrete ring beam, not just a 100 kPa prepared earthen slab. The reason being is that this is a cyclone region. So under Australian design codes for wind loading, it's very simple and easy for us to adopt this. Putting that concrete ring beam and tying the structure down gives us that compliance. And we have these installed in northwest WA for exactly the same reason. So there you go, just a bit of a snapshot of our business and solutions. Very different when you think of tanks these days. You can now think of dam and pond replacements, not just, I guess, big structures. So that's Concept Tanks, and we're here all week if you'd like to come and drop by and have a chat.
All right. Thanks for that, Andrew. We did let that one run over a little bit, but I like the topic, particularly around containment of fluids that might leach into our environment. Obviously, PFAS is something that's very close to home for us in the fire industry, and we've seen how that can go wrong. Solutions like this can prevent that contamination moving through groundwater and things like that, preventing it from getting there in the first place. Last on our speaker list, Louis Longy from Australian Specialty Coatings.
Thank you. I'll promise to keep this as quick as possible. Today I'm going to talk about the role of industrial floor toppings in the waste industry. Essentially, most disposal sheds, most tipping sheds at some stage will come to a realisation that the concrete has been worn away either by leachate or by front-end loader movements. I'll just give you a quick rundown of what we actually do. We protect various coatings and various products in the waste industry. So if we look through here, industrial flooring, bunding for a lot of the waste water and leachate industries, and corrosion control. That's what our business actually does. I'm going to just talk today, though, about tipping shed floors and essentially how, in the past, what's usually happened is when a tipping shed floor has got to this stage of the reinforced steel, usually the way it was done in the past, they would close the site down, they would pour a 20 or 30 mil slab over the top, and you'd be out of action for about 28 days. We've developed a system over the last 15 years that can have you back into action for the next day and actually keep the site open. This picture here is like the cause of damage, and it's a perfect picture to show you what generally does it. You can see the leachate running out of the putrescible waste there. It slowly erodes the fines at the top of the concrete. So as they pour the concrete, the weakest part is usually the top. All the blue metal, all of the bigger aggregates tend to go to the bottom. But essentially, the top of the concrete is usually the weakest, even if it's been protected with some sort of coating. Here's one of your sort of big issues is the front end loader. The front end loader in some of these sites are taking up to 700,000 or 800,000 tonnes a year now. Certainly some of the ones in Sydney. What these guys have done here, and this is at Veolia, but they've put a rubber band over the front of that, a big rubber blade, and it protects the floor, especially when the floor has been repaired. Let's move on to the next pic. So this is what you'll often see. Not only have you worn away the top of the slab, but you've also now come down to the reinforced steel. And that should be, in theory, 100 mil, or about 100 mil under the surface. This site here was 3 months old, and they've done 100 mil of concrete in 3 months. And this is a big issue, because once you get below that, you're going to start pulling that Rio up. The Rio is going to bend. You're going to lose the integrity of the slab, as you will see in this next picture. So you can see what's happened there. The front end loader has caught the reinforced steel. It's pulling it out. And what generally happens here is that people will come now and have to cut that out. And every time you do that, that slab gets weaker. And as most of these are floating slabs, you're going to have, and it's happened a few times around Australia, the slab will actually crack. Okay, and then you're out of action for however long it takes engineers to come in and sort this out. And it's usually a long amount of time. So what I'm going to show you now is a case study of a client. This is actually Cleanaway, but Veolia, you name it, across Australia, we've done most of the sort of the bigger sites. But this was a site that was relatively new. It was 3 years old when they contacted us. And you can see essentially what they had is they had 1,200 square metres of floor. The site's much bigger than that, but they had 1,200 square metres of floor that putrescible waste had eaten through the slab, as you'd seen in those previous pictures, and it was starting to get a dip in the middle of the slab. And big issue is like, well, if it's only this old, what's it going to look like in 5 years' time? And slabs, they erode faster, obviously, the more aggregate that starts to be exposed. So it gets knocked out with the front of the loader, with, movements of cranes and stuff going in there. Okay, so this was this actual site. This is the leachate attack you can see on the left-hand side. Putrescible waste, it's one of the biggest issues. Exposed aggregates, that's what the floor looked like after we blasted it. And there's cracking in that middle photo. I don't know if you can see it, but in the sort of the top left corner, the slab has actually cracked. And then exposed steel. That's starting to corrode, and that's a fairly big issue. So this is what we had to do. The surface that we've developed essentially can go down and be ready for action in 24 hours. So if we were to lay it on a Sunday, you're in action on Monday. This is the system that we chose for this site. It's a primer that goes down. Then you get the resin, which is resin and aggregates, special aggregates, and then there's a top coat to let the resin underneath, which takes 7 days to chemically cure while that top coat is curing over the top. Just a side view of what it probably looks like. It's a bit exaggerated, but that's what a floor would look like once it's been blasted and cleaned on the left. Exposed aggregates of various different sizes and steel. And on the right, you can see what it's going to look like when it's done. So a resin is poured down first. That fills up all of the issues. And then a coating over the top of that, what we call the wear slab. And then over the top of that, you'll have a coating that lets everything seal. So I'll show you the process. The first part of this, we get a truck in and basically the floor is high pressure washed down just because there's a lot of shit in the floor and it needs to be cleaned properly. We can blast it, we abrasive blast it, but this way it's a bit quicker. It allows the abrasive blaster to move fast through there much quicker. This is the next stage. Now this is open abrasive blasting with garnet, which is perfectly fine to do, but we can also shot blast it depending on how bad the floor's got. I mean, if you've got a really bad floor, we've got to put a big machine across that floor, you have to use an abrasive blaster. If the floor's not too bad and you've got it at a fairly decent level, a shot blaster can do that job for us. And this is how we work the floor. So this was the bit you saw in the red floor. The reason we colour it this colour is twofold. One, we can see obviously where it's been poured, but two, in the future, when you actually go through the topping, which inevitably you will do because they are wear slabs, you will see, when you start to see this colour, you know it's time to have a look at that area. What's good about this is if you have a big shed and you've got certain movements, you can just repair those areas. You don't have to do the whole thing. It's not like a concrete floor. You need to cut the whole thing out. You can just go, right, we've established there and there in front of the compactors need a bit more work than the others. Okay, so this is the guys putting the floor down. It's a proprietary mix of resins and aggregates, but it's designed specifically for leachate attack, and it's got a higher MPa than concrete. So if a concrete goes down 32 MPa, this you'll be getting about 60 or 70. So it's actually a lot harder than concrete. It can go down at any particular depth, but 20 mil, it's expensive. So 20 mil is about what you want, and it's troweled out by hand, as you can see. Once that's gone down, 3 hours later, an acid-resistant top coat goes on there. Now, the reason this is all many different colours is because at this site, they wanted to work out where their loader movements were going. So we purposely coloured this to work out, have any of these worn out faster than others before they get down to the bottom bit. And this essentially is why we've done this is we go back every 6 months to all of the sites and we check, and we can tell it just by looking at the colour. So here we've done this crazy colour scheme, but nevertheless it works because they can work out what's actually happened to their slab. This is 3 years old, and that top coat's still there, and that top coat's only 2 mil. And this essentially is the complete job. This is on another site. But that's what it looks like when the guys have actually put the floor down. It's dried, it's cured. It can be done. Mostly what happens is these sites don't stop. So we will do them over a weekend. Guys will go in there on Friday night. They'll put the barricades up. It'll be blasted. They'll trowel it in on Saturday, do a top coat on Sunday, and they're back onto it, usually Sunday night or Monday morning. So, comparing that to concrete, you're out of action for a long time. This is stronger and it's completely leachate resistant. And as I promised, that's that. Okay. Any questions? No, good. All right, super. Thank you.
All right, thanks, Louis. That's taught me more than I knew about floorings and industrial applications than I knew before. But again, lots of great concepts and ideas. The different colours in the layers to see where the exposure limits are being met, so we can treat it again. Great ideas. Team, we'll open to the floor. If you have any other questions, I suppose we've had a little bit of time through the course of the discussions, but did anybody have anything they wanted to ask of our presenters again today, now that we're finished? Yes? Sorry. Thanks, Mitch.
Holly Jenkins from Singleton Council. I'm just double checking with the container deposit scheme whether or not there is a discussion to upgrade the New South Wales system to incorporate wine bottles as well as spirit bottles.
Oh, that's a great question. I'm sure there's many ladies wanting to know the answer to that one as well.
I might need some help with this one. So don't quote me on this. I think that there are some discussions, but I'm honestly not across where they're at the moment. So obviously, Queensland container deposit scheme does take wine and spirit bottles. If memory serves, the WA Labor government pledged to do it if they won the recent election. So I suppose we're waiting to see when they follow through with that. In terms of other states, I'm not sure where they're at with those decisions. Apologies, I couldn't give you a good answer on that one.
That sounds like a great red and blue competition. I love to hear that Queensland's in front. Anybody else? No, look, as I said, I think we've had some great discussions and concept ideas, some already in place and working quite well. It's great to see so many Australian initiatives in this space. All the presenters, I believe, have exhibit stands inside, so please take the time to catch up with them through Waste 2025 and ask some more questions, as I'm sure you'll remember as you walk out the door today. And I'm wandering around as well, not exhibiting unfortunately, but by all means pull up for a chat about any fire safety equipment and security solutions you might have as well. So thank you everybody.